Hey everybody, so this is synthetic division. So in our last video we looked at how to divide polynomials with long division, which always works, but here we're going to learn kind of a shortcut hand as long as certain stipulations are met. So this is going to look like total voodoo magic. I swear it's not. I didn't make this up. This is real stuff. So synthetic division can only be used when your divisor is a linear factor, like x minus 2, x plus 8, or 2x minus 4. Basically, your x is to the first power. There's no squareds, cubes, nothing. So your divisor has to be linear. This is primarily used to help us to find zeros. So that's why we're learning this now, because in the future we're going to learn, okay, well, how do I find all of my zeros? So if we can find one of our zeros, synthetic division will help us to find the rest of them. So that's primarily what we use it for. The other stipulation is the leading coefficient of the divisor must be 1. If not, we have to make it 1. So like these are all 1s. That's 1. That leading coefficient is not 1, so we're going to have to mess with this in order to use the synthetic division. And we'll see an example of how to do that. But as long as you have a linear factor, you're good to go. Sorry, a linear divisor. And again, this is going to look like I made it up, but I promise it's backed up by real math. So let's see how this goes. And also, if you don't like this, long division will also always work. This is just kind of a shorter shortcut way, and it'll save you some room as well. So first example, 2x cubed plus 5x squared plus 9 divided by x plus 3. So we could launch into long division if we want, but let's see how to do this kind of shorthand. So first things first, our leading coefficient is a 1, so that's good, and this is a linear divisor, so we're good to go. So first thing, I need to set my denominator equal to 0. So I need to solve x plus 3 equal to 0, minus 3 on both sides, so x is going to equal negative 3. With this negative 3, I'm going to put it in a little window up here, and then I'm going to write all of the coefficients of my polynomial in descending order. Oh no, it looks like we're missing an x term, so I'm going to sub in there 0x. Always in division, if you have missing terms, you need to put them in. So my coefficients then will be 2, 5, 0, that was the missing x term, and 9. And then I'm going to draw a line underneath. Okay, first step, the 2 just comes straight down. And then I multiply my little window number by the number that came straight down, and then I put that here. So this is kind of like what we do in division. Negative 3 times 2 is negative 6. And then I add them together. So that's very important. And then we add them together. So 5 plus negative 6, this would give me negative 1. Okay, and then same thing, I'm going to multiply these two guys. So negative 3 times negative 1, that'll give me positive 3. I don't want that, I want it in pink. Positive 3, and then I add these together, and that gives me 3. And now, same thing, I'm going to take negative 3 and I'm going to multiply it by 3. That number is going to go here, there. Negative 3 times 3 is negative 9. Again, I now add these together, and that's going to give me 0. So this guy here is remainder. But if the remainder is 0, we don't have a remainder. Okay, so by synthetic division, this guy, so 2x cubed plus 5x squared plus 9 divided by x plus 3 equals 2. So my leading coefficient was a 2. I dropped the power by 1 to x squared minus x plus 3 plus 0 remainder. So again, so that guy became 2x squared. This guy became minus x. This guy became plus 3, and then no remainder. Okay, so what you get as your numbers, we write them now, we fill in our x squareds, our x or whatever have we, but make sure you start with the exponent that's 1 less than the exponent of the polynomial that you divided by. Okay, so much shorter than long division, but maybe a little more confusing. So let's do another example. So our next example, 2x cubed minus 5x squared plus 3x plus 7 divided by x minus 2. I can use synthetic division because linear factor, my lead coefficient is 1, so I don't have to do anything to my linear factor. First step, solve x minus 2 equals 0. In other words, we want to get the 0 out of this. So add 2 on both sides. So x is going to equal 2. So 2 is my window number. Okay, and then I take the coefficients of my polynomial. So I have third, second, 1, 0. So I don't need to fill any missing pieces in here. So I'm going to take the 2, I'm going to take the negative 5, I'm going to take the 3, and I'm going to take the 7. I'm going to draw my little bar under here, and we're going to go. 2 drops down, so this first number always drops down, and then we multiply and add. Okay, multiply, 2 times 2 is 4, so we multiply, that guy goes there, we add these together, so negative 5 plus 4 is negative 1, okay, then multiply and add, okay, now 2 times negative 1 is going to go there, and then whatever we get, we're going to add it. 2 times negative 1 is negative 2, 3 plus negative 2 is positive 1, okay, same thing, multiply and add, multiply, that's going to go there, and whatever we get, we're going to add it. 2 times 1 is 2, so 7 plus 2 is going to give me 9. This last number is always our remainder. So this did not go in evenly. Okay, so as a polynomial now, so I have the coefficients, now let me reconstruct the polynomial. I always start with 1 less. Okay, so this is going to be 2x squared minus 1x plus 1 plus, and I did plus because that's positive 9. We always write the remainder as a fraction, 9 over x minus 2. The remainder is always remaining number divided by whatever your divisor is. So this divided by this equals 2x squared minus x plus 1 plus 9 over x minus 2. And this here would be our final answer. Okay, let's look at one more example. And the next example I have is, well, what if the lead coefficient here isn't 1? What do I do? Well, I will tell you. So, the lead coefficient here is not a 1. What do we do? Well, we're still going to solve it out. Okay? So, I'm still going to solve 2x minus 1 equals 0. Add 1 on both sides. We'd get 2x equals 1. Divide both sides by 2. We would get x equals 1 divided by 2. So 1/2 now is going to be our window number, and instead of 2x minus 1, we're going to change this into x minus 1/2. Why did I put a minus in there? Because our 0 was a positive 1/2, so if I plug in positive 1/2, 1/2 minus 1/2 is 0. Okay? Or you can think the opposite. Alright, so that's now our new linear factor, or a new linear divisor. Okay. Do my coefficients. So I got a 3, I got a 2, then a 1, then a number. Okay, good. So I don't have to fill in any zeros here. So my coefficients are 4, then negative 8, then negative 1, so this will be a negative 1, then positive 5, and then I throw my line in here. Okay. Positive 4 comes straight down, and now we're just going to multiply and add. Multiply. That number goes there, and then I'm going to add it. So it's always multiply and add. Actually, let me bring my pen closer to me, because this will make everything so much easier. Okay. 1/2 times 4 is 2. Whoa. 2. There we go. Negative 8 plus 2 is going to give us negative 6. Okay, multiply and add. Multiply and add. 1/2 of negative 6 is negative 3. Add these guys together. We'll get negative 4. Multiply and add. Multiply, add. So 1/2 times negative 4 is negative 2. Add these together. 5 plus negative 2, or just think about what is 5 minus 2. Well, that'll be positive 3. This last number here is always our remainder. Alright, so let's reconstruct the polynomial then. We always start with 1 power less, so we're going to start with a square. So this would be 4x squared minus 6x minus 4. That's positive, so plus 3 over our new divisor, x minus 1/2. Okay, so this guy divided by this guy is going to be 4x squared minus 6x minus 4 plus 3 over x minus 1/2. Okay? Alright, so that's it. Please ask questions. Also, we're going to practice this a whole bunch. So synthetic division is very algorithmic. It's a lot of, hey, I just need to get used to this. So that's the next step. It's like, hey, okay, now let's get used to this. And just know synthetic division is just a tool. What we're really after is finding zeros of these polynomials. But this is a tool that we're going to use. Okay? So always, please ask questions if you have them.